Hi, this is Mrs. Basin, and today we're going to talk about the properties of gases. So some general properties of gases to start out with. Gases will fill the container, so they will take the volume of whatever container they're in. They're compressible, which means you can take a large amount of gas and squeeze it into a much smaller container. They mix with other gases because they're in constant random motion. They will randomly mix with other gases near them. They exert pressure on their surroundings. So pressure, by definition, is force per unit area. So if you actually wanted to calculate a value for pressure, you would take the force that's being exerted divided by the area over which it's being exerted. For now, we're not going to actually calculate pressure, but we need to know that gases exert pressure because as they move and they bounce into the walls of whatever container they're in, that bouncing against the walls creates what's called pressure. The air around us is a mixture of gases. So this little chart here shows us that most of the air that we breathe is made up of nitrogen. There is a lot of oxygen in there because that's something that we need. There's a tiny bit of argon, a little bit of carbon dioxide, and then you also have some water vapor in there. Then the rest of that total percentage are just trace amounts of other gases. Because there's this mixture of gases around us, those gases exert pressure. So we call that atmospheric pressure. We know that the pressure changes with changing weather. So if you think about when you listen to the news, they will give the atmospheric pressure and the meteorologist will say the pressure is rising or the pressure is falling, and that changes depending on what kind of weather we're getting ready to have. It also changes with altitude. So the higher the altitude, you've heard the thinner the air, because the air is there's less air molecules at a higher altitude, there's a much lower pressure. And then we measure atmospheric pressure with an instrument called a barometer. At sea level, our pressure is equal to 1 atm. Where we live, our atmospheric pressure is usually really, really close to 1 atm as well. There's several units to describe pressure. Depending on where you're talking about pressure, you're going to see different units. One unit is millimeters of mercury because a barometer has mercury in it, or an older barometer has mercury in it. So the millimeters, how many millimeters of mercury are up the barometer, that's one particular measurement. Torr is another measurement. An ATM is another one. So 1 ATM is equal to 760 millimeters of mercury, which is equal to 760 torr. A Pascal is 101,325. Pascals is equal to 1 ATM. And then one that you maybe have heard of is pounds per square inch, or PSI. So 1 ATM is equal to 14.69 PSI. If you listen on the news and hear them talk about pressure, you'll hear them say that the pressure is so many inches and rising or so many inches and falling. So they're measuring it in inches of mercury instead of millimeters of mercury like we do here. So these are important because a lot of times the pressure might be given in one unit, but we have to convert it to use it in one of the formulas we're going to look at in a little bit. So we have to do a little bit of practice here first with just some basic conversions. So we're going to do one example problem here. So our example problem is the pressure of the air in a tire is measured to be 28 psi, or pounds per square inch. What is that pressure in atmospheres? Okay, so just like we've always done, whenever we do a conversion, we're going to start with the number they give us, to 28 psi, and if you go back to your list of conversions, and I'll give you a list to put in your notebooks as a reference, we know that 1 ATM, because that's what we're trying to convert to, is equal to 14.69 psi. So these are just like the conversions that we've been doing over and over, just different units than what we've used before. So you multiply going across, you divide top to bottom, just like we've been doing, and we end up with 1.9 ATM. So the pressure in that tire is about twice what our regular atmospheric pressure is.